Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, thanks everybody for coming today to come see Jimmy Lin give a talk on end-user creation of mashups and cross-device UI prototypes. Jimmy and I have known each other since grad school at Berkeley. We're in the same year and spent about as much time together as you could possibly can in grad school in terms of length of tenure. He recently took pictures of our respective dissertations from the Berkeley Library, and his was over twice as large as everybody else's. So Jimmy's a little bit of an overachiever. He has, since graduating from Berkeley with his PhD in computer science, with doing HCI stuff with James Landay, he went on to IBM Almaden, where he did a lot of stuff on scripting, web scripting, sort of end-user programming stuff, as well as he's always been kind of interested in helping website designers and people prototype types of applications. So since a couple years ago, he moved on from IBM Almaden over to Google, and he's now working on some fun practical things, as well as some side projects that are still sort of researchy. But thanks very much for coming, Jimmy. I'll let you take it away.
All right. Thanks, Andy, for that introduction. So today I'm going to be talking about a couple projects that I've done in end-user programming. And so what is end-user programming? It's the idea of bringing at least some of the power of programming to non-programmers. So for example, allowing people who don't program to modify existing applications or websites, or to automate repetitive tasks. And the way we approach these problems is, among other things, to leverage concepts and metaphors that are familiar with our target audiences. So for example, one project that I'll be talking about is looking at helping UI designers create interactive prototypes. And so the concepts and metaphors that we leverage in that project are design patterns, layers, similar to those in Photoshop, and storyboarding. And that project is called Damask. And then the other project I'll talk about is helping end users integrate data from multiple websites. And we'll use the concept of spreadsheets. And that project is called Vegemite. So first I'll talk about Damask. And this is work that I did with James Landay, who's now professor at of computer science at the University of Washington. And so, as you know, the role of PCs is increasingly being augmented by those of mobile devices, and for accessing content online and so on. And these devices are getting more and more powerful. Being able to access the web now on mobile phones is much better experience than it was just a few years ago. But they're still not perfect in that most of the content that's being created for the web today is still targeted towards traditional PCs. So for example, if we took the standard Twitter homepage and looked at it on a mobile phone, it's going to look something like this. So the fonts are really small, and there's all this stuff going on the right-hand side, and it's hard to get to kind of the meat of the content. And that's because this was formatted for a screen with at least 3 times the width of the phone. But thankfully, this is not what you see when you go to Twitter's homepage on a mobile phone. You see something like this. So where the fonts are much bigger, so you can actually read the content, and it also strips away some of the things that you probably don't need to do on a mobile phone. And so we wanted to look at how designers approach this type of problem of designing for multiple types of devices. And so what we did is I interviewed 9 UI designers. Each of those designers were designing user interfaces for more than one device, desktops and either PDAs or mobile phones. And there are a few things that we found. One was that the mobile UIs typically were a subset of the desktop UI in terms of functionality. We found that the tools and the processes that they used were pretty similar to that of web design, which we studied for the Denim project, which I worked on previously. And so they did a lot of sketching, storyboarding, using tools like Visio or Photoshop to make prototypes and so on. We did find that people tended to do somewhat less sketching, on paper and so on, and more wireframing using tools like Visio, because the phone screens are small enough that people just felt they could just go ahead and do things on the computer. Our designers talked about how hard it was to keep designs consistent across devices. So, keeping the flows consistent where it made sense across devices, keeping terminology consistent. And then they also told us that they found patterns that they would kind of go back to solve common multi-device UI design issues. And in fact, one of the designers that we talked to said that their company was starting to collect a bunch of patterns all about designing for mobile phones and having some type of desktop equivalent. So we took these findings and created a design tool called Damask. It's a tool for designing these cross-device UIs and to be able to create interactive prototypes of them without programming, early stage lo-fi prototypes. And Damask targets 3 types of devices: viewing the web on a desktop or laptop, smartphones, and prompt and response style voice interfaces. And Damask incorporates design patterns and layers to help designers retarget UIs created for one device for other devices. So here's a screenshot of Damask. In the center, we have a canvas area. That's where the designers can sketch out their pages, and they sketch out the contents within them, and they also draw arrows in between the pages, and that signifies how to transition from one page to another. That's the user's flow. On the left-hand side is a fairly standard toolbox with some sketching tools, and also being able to add widgets, radio buttons, checkboxes, and so on. And then there's a zoom slider here where you can zoom in and out to see your design. And so now I'm going to talk about 2 more concepts here. The first one is layers. And so now I'm going to switch to the video. So along the top here, you can see 3 tabs, 1 tab for each of the target devices: desktops, smartphones, and voice. And then on the left-hand side, we see 2 radio buttons, 1 layer for elements that are in all devices, and another layer for elements that are only in a particular device. So right now, I'm creating a desktop page in the all devices layer. That means that this page will also appear in the smartphone and voice devices, because it's in all devices. And I'm still in the all devices layer. I'm going to create some content here. But now I want to create maybe a graphic, and I only want that graphic to show up in the desktop version. So I switch to the this device layer, I draw my content, and you can see that it does not show up in the smartphone or the voice. Now suppose I'm in the smartphone version, I see some content that I decide I only want in the desktop version. So I switch back to the desktop version, and I select that text, and I push it from the all devices layer into the this device layer. And when I do that, then it disappears from the smartphone and the voice versions. So that's layers. Now I'll talk about design patterns. So Damask includes a collection of 90 design patterns from the book The Design of Sites by Doug Van Dyne, James Landay, and Jason Hong, available at fine bookstores everywhere. So let's take a look at one of these patterns in more detail. So you can see that this pattern, this payment method pattern, how am I going to pay for an item? It has a background image, it has a problem statement, a solution statement, but some of these patterns include Damask solutions that you can incorporate into your design. Here's the desktop version of that pattern. We have pages for creating, adding a new credit card or editing credit cards. You can see that the smartphone version of this pattern does not have those pages, but it has a different content. It has a way to allow you to pay through your mobile phone. And then the voice version is totally different. It just asks you for a credit card number. And so you can see that the pattern can encapsulate these very different modes of interaction, but they conceptually mean the same thing. So to use a pattern, the designer drags from the pattern browser onto their canvas, and that pattern gets added. And that pattern gets added for all of the various devices. So we can see it's been added to the smartphone, it's been added to the voice, and you notice that when I connected the pages together in desktop, it also connected them in the other two devices. So I'm going to go here, I'm going to just muck with the text a little bit, change MasterCard to American Express. And now I'm going to run my prototype. So now I have an interactive prototype that I can actually run without programming. And so you can see here I got a fake web browser. I can go ahead, I can click on buttons and so on. I can type in text. I think this looks pretty good. Now let's take a look at the smartphone version. You can see, first of all, that the text changed because I was in the all devices layer, so it also changed on the smartphone. Now I can click play, and you can see this incredibly ugly mobile phone emulator, but I can see that I can actually go ahead and use the mobile phone version of my site. And for the voice version, Damask can export as voice XML, and then you can import that voice XML file into a service like Tellme, and then you can call Tellme and actually play around with your voice interfaces that way. Okay, so now I'm switching back to the slides, and I'll talk about evaluation of Damask. So we wanted to see how well did Damask work in this domain of cross-device UI design. Particularly, do the ideas of design patterns and layers make sense in this domain? So what we did is we recruited 12 professional UI designers. 8 of them work on both desktop, web, and mobile phone sites, and 4 of them work on voice UIs. And each of the designers used Damask over 2 sessions. In one session, they used Damask without design patterns and layers. We disabled those features. And in the other session, they used it with design patterns and layers. And we also gave them 10 minutes to look through the 90 patterns and familiarize themselves with them. And we randomized the order to account for learning effects. And then afterwards, after a short demo, we asked them to design a basic e-commerce website. For one session, it was books, and for the other session, it was music. And we had them designed for 2 devices, for desktop and either smartphone or voice, depending on their background. We didn't ask them to design for all 3 because it would just take too long. Each session was already took about an hour. So one of the things we wanted to find was what were the differences between the designs that were created with and without design patterns and layers. So we asked 34 more professional designers to look at the designs that the 12 designers created. So what I did was I went through all the designs, I cleaned them up, I changed the handwriting so the handwriting was all the same so that wouldn't be a factor. I uploaded them onto a website, and I assigned 4 designs to each judge. And what the judges did not know was that the 4 designs came from 2 designers. One where they created it with patterns and one where they created it without patterns. And then we crunched the numbers, and we found a few interesting statistically significant differences. We asked the judges to rate the designs on several properties. How well were the designs, how well were the pages laid out? How well were the pages linked together? How complete was the design given the design statement that we gave the designers? And then an overall rating of how good the design was. And so for the desktop versions, we found that there were statistically significant differences where the designs created with patterns and layers were rated better in the layout of the checkout pages, in the completeness of the design, how many things they were able to cover in the design problem, and in the overall rating how good is the design. For smartphone, we found the designs created with patterns and layers were rated better overall in the layout of the checkout pages and in the completeness of the design. And then for voice, we didn't find any statistically significant differences. And we've thought of two possibilities why. One is that we only ran 4 voice designers. And so it's hard to find differences that way. They also didn't have web UI experience. So, although actually that shouldn't make a difference in this case. But the other possibility is that I'm much less familiar with voice UI design than web UI design. I've studied web design much more, and I created all of the patterns. So it's very possible that the voice patterns simply weren't very good, and that's why we didn't get good differences. So yeah.
Did the judges have voice design experience?
The judges, well, that was another issue. It was hard to find. So the judges also did not have voice design experience, but what they did was that they, the way they evaluated those designs is they actually picked up the phone and went through the design. And so that was almost more of a usability thing. Could they accomplish what they needed to accomplish? So yeah, it was slightly different, but that's another factor. Okay, so that covers the designs that were created. Now, how good was the tool? What did the designers themselves think about using the tool? And did they use design patterns and layers, the concepts that we gave them? So we had, like I said, 12 designers. And there were 11 design patterns within Damask that were extended that had Damask solutions that they could drag in. So they could use a maximum of 11 patterns in this design task. And you can see all but 3 of the designers used 8 or more patterns. And all but 2 used 6 or more patterns. And we think this is pretty good, given the fact that they only had 10 minutes to familiarize themselves with the collection. They found that the patterns were compelling enough to use without much training. Now, as you can see, there were 2 designers that basically didn't use the patterns. We'll get into those. We'll get into those reasons later. Yes.
Were there any patterns that explicitly solved the exact problem you were asking them to do?
Yeah, I mean it was that the patterns that we created were geared towards the particular task. So, the fact that they used the patterns was more about the fact that they found the patterns in this collection of 90, that they were organized reasonably well, and that they decided to use them. So it was, obviously once you use them, it's going to be much more helpful for this design task. But those were the types of questions that we were looking for. And you can see that 2 of the designers still didn't use any of the patterns, even though the patterns were there to really help them with this particular task. So it wasn't necessarily obvious that they would go ahead and use them. One thing I should explain about implicit versus explicit, some patterns contain other patterns. So, for example, user number 4, all the way on the left, explicitly dragged 5 patterns from the pattern browser into their design. But one of those patterns includes a bunch of other patterns. So that means 11 patterns were ultimately embedded in that design. So we asked the designers how useful they thought the patterns were for this particular task and in general. Not surprisingly, most people found that the patterns were very useful for that particular task. And the only person who didn't was the person that used 0 patterns. When we asked them about it in general, they were still pretty positive. A mean of about 5 on a Likert scale of 7. And when we asked them what they liked and didn't like about patterns, they liked that patterns save them from reinventing the wheel, that there were these common design problems, pretty well-known solutions, they might as well just use the pattern. And that the patterns themselves, the solutions only include the core of what was needed to solve that particular problem. Now, there were some issues with using patterns in Damask. And one of them was that it was hard for the designers to deal with very large patterns. One of the patterns that they could have used had something like 8 or 10 pages and all sorts of content within the pages and links and so on. So when they dragged the pattern into their design, all of a sudden all this stuff got dumped into their design. They don't know what the pages are for. They don't know what the content is in there, and they'd have to spend quite a bit of time navigating through navigating through the pattern instance to see what happened. And this happened on all 3 devices. So then they would go to smartphone and then see like 15 new pages, and then go through the same process over again. So we should be able to annotate patterns a bit more, so that they can get a gestalt of what's going on. Maybe we don't have to show all of the pages at once. They could be collapsible and so on. But just not make dealing with large patterns so overwhelming. They also said that it was hard to keep track of 90 patterns, which is no surprise, given that they only had 10 minutes. And we think that this problem would decrease over time. And we think they did pretty well, given that. As I mentioned, 2 of the designers didn't use patterns at all. And when we asked them why, they said that they felt that patterns were not necessary for such a simple task. They had done this before. They'd just go ahead and do it from past experience, and that they didn't have enough time to familiarize themselves with the patterns, and so therefore they just didn't bother. They didn't want to go back and try to find them again. But yes.
Did you time how long it took everyone to complete their tasks?
Yeah, the timing, it was roughly, it wasn't significant in terms of how it interacted with kind of their reaction. I think it ranged anywhere from an hour to an hour and a half per session, basically.
The people who didn't use patterns were significantly slower.
They weren't significantly slower because the people who did use the patterns, they still spent time kind of understanding the patterns and so on. So it was kind of a wash in that sense. Mm-hmm.
So what was the background of these designers? Did they have programming experience before, or what tools did they use before?
I'm trying to remember. It's all in the paper this was published in Kai 2008. They did not have significant programming experience, and that certainly was not their day-to-day job. So they didn't have, constant programming experience. And the tools that they used kind of ranged the gamut in terms of like Photoshop and Visio and PowerPoint, and it was kind of a fairly standard set of tools that you see a lot of designers use. Mm-hmm.
Earlier you said that the experts rated the designs that use the patterns better on some different sets of metrics, right?
Yeah.
But there were only 2 people didn't use patterns. Were the experts able to rate, or was that description that some people use patterns, including even if you just use one? Or is it, are the ones who didn't use patterns, are we only talking about these 2 people?
Yeah, so when the designs that used patterns, so it's the designs that actually used patterns, not just those that were in the patterns condition, basically. So we decided for that, I believe, yeah, I actually don't remember exactly right now, but yeah.
Do these patterns carry over to a non-hyperlinked development model? Most of the mobile stuff is now apps. There are very few that people consume through websites. So, but on the other hand, on the PC, they're still going to create websites.
Right.
It's the same set. Do they carry over pretty well to an app-driven world?
I mean, I don't see any. We haven't created patterns like that, but I haven't seen any reason why the patterns couldn't carry over to that type of model, because
How much of it is hyperlink driven versus tabs and pagination driven, which is more for, like role pagination, right?
Right. So, I mean, you could have patterns that have kind of vastly different interaction models between the different devices. I mean, I think the voice shows that. The voice is very, very different. And so there are ways between voice and the desktop to kind of keep the terminology the same, but the interaction flow is going to be quite different. And so I think the combination of having patterns that could deal with kind of mobile apps versus desktop websites, where you could deal at a higher level, and some of those transitions are already taken care of for you, I believe patterns would be able to handle that. Any other questions?
These were UI designers, not graphics designers.
That's right. So they're UI designers, they're interaction designers.
So do they feel at all that this took away from the value they bring to the job, or threaten their creativity?
Right. They didn't feel that. I mean, that was one of the things that we were kind of wondering about. Like, will these patterns, impose these solutions that that would take away from them? And they actually didn't express those types of opinions. I don't believe we prompted them, but they never said that. So, the patterns themselves are tricky because they're almost like dictionaries in the sense that there are people who believe that patterns should prescribe best practices, and there are those who believe that they should only describe what's actually being used out there. It's kind of one or the other. The patterns that were included here, the authors of the book were following a descriptive model. It's like, this is what is actually going on. Of course, there's kind of interaction between the two. Once it gets codified, then people, could start treating it as prescriptive. One thing that I wanted to do that I didn't get a chance to do was to have multiple types of examples within a pattern. And actually, that is something that the designers themselves said that they would like. So there's like a homepage pattern. Like, here is an example of a homepage. But a homepage can appear in so many different ways for different types of genres. And so if we provided like a whole bunch of different examples, that might help kind of alleviate those who may feel that it stifles their creativity.
And I guess the follow-up question is, how much value did they add after they put the pattern in? I mean, did they do a lot of changes? Did they?
Yeah, they didn't do. Right, yeah. I mean, the people who used the patterns most heavily did not do that many changes. And so for that, so in a way I have kind of mixed feelings about that, right? Because it's like, well, these patterns, I didn't intend these patterns to be prescriptive. So I was like, well, what I did was I added things into the design task so that it did not exactly fit the patterns. So I said, you must add these features, and made sure that the patterns did not cover them to make it specific. So they at least modified, pages and stuff to add those features, but they didn't drastically change the layout of the pages or anything like that. Probably for a more well-specified design problem, kind of realistic, where you have more and more requirements, it would probably force them to do that. But okay,
Did users tend to use the first pattern they selected and tweak it and make it work for the particular problem, or did they tend to try a bunch of patterns and then throw away their work until they found one that was appropriate?
They didn't tend to throw away patterns that they used, from what I remember. I think they did spend they would spend a fair amount of time within the pattern browser to make sure that they were selecting the right pattern, and then once they incorporated it, if they decided not to use it, it would be almost right away. I don't remember seeing them use a pattern, kind of fiddle with it for a while, and then say, oh, this wasn't what I wanted, and then toss it. And I think it's because that the patterns and the sketched pages that we provided them, lent enough detail that they could already decide that this was appropriate or not.
Could they actually test the pattern in the pattern browser?
Yes, they could. Yeah, there was a way to actually click play, and they could try it out before incorporating it. So that would be another way. Yeah.
So then, was there a high degree of overlap among the users for the patterns they selected?
Yeah. Yes, there was. I don't remember off the top of my head, but there was definitely. I mean, so most of the people used most of the patterns, and there were only 11. Most of the people used a lot of patterns, and there was only a set of 11 patterns that they could use. So if they used a lot of patterns, they were all using the same patterns. There was a section in the pattern browser that said, these are e-commerce patterns. So if you saw that or not, I think that would help determine whether you bothered using the patterns or not. They're all here. So, I mean, they weren't all in that block, but a lot of them were in that block. Okay, let's see, moving on. So patterns had pretty good a positive reaction. Layers had a more mixed reaction. So when we asked the designers whether they thought layers were easy to understand and whether they like layers, you can see that there's essentially a bimodal distribution. Like maybe a few more people like layers than not, but it's definitely double peaked. One thing I noticed though is that the person who used 0 patterns really liked the layers. So it's good to know that she got something out of this tool. So when we asked them for their opinions about layers, we found it seems like the concept has promise. Like everyone understood, oh, layers, it's like Photoshop layers. But the details need work. And the main problem that we found is that people accidentally added or removed items from the wrong layer and therefore from the wrong device. And this seems to be a problem with layer-based UIs no matter what app you use. So for example, people would create designs in the desktop version, go to smartphone, add more stuff, go back to desktop, and then try to figure out why all this stuff had suddenly been added to their desktop page. And so maybe we need to set the default layer for these other devices to this device only, so you're not accidentally adding things to all of your devices. Although I have a feeling that's more of a Band-Aid than anything. So I think there's some kind of rethinking of the layers concept that needs to happen. A bigger problem was removing objects. So I demonstrated in the video that there's a piece of text in the smartphone version that the designer didn't want, so they have to go back to the desktop version and then move objects between layers. Most of our designers didn't get this, so they would just see the thing and say, I don't want this, grab the eraser and erase it, and then go back to the desktop version and wonder where that content just disappeared to, since they just erased it from all layers. And this isn't terribly surprising after the fact, right? So once again, I think we either need to augment the concept of layers or have better tools to make clear the consequences of dealing with objects and layers. Mm-hmm.
So you personally did the 90 patterns in all 3 devices?
So we only added Damask solutions to 11 of the 90. But yes, I did them personally for all 3 devices.
So having done that, I'm curious if you think there's opportunity for a tool to operate on a model of kind of the pattern and then generate the device specifics.
Yeah. So I think there's a whole set of model-based UI research that's all about describing a UI in terms of an abstract model and then generating specific UIs. There may be value in that. It certainly was. It certainly took me a while to create those, but in many instances, it wouldn't have helped me as much. So, for example, in the payment method one, there's 3 pages and allowing people to add credit card information and so on, and the voice interface didn't have that functionality at all. So it was vastly different. It's just like enter your credit card number, done. So a lot of these patterns were at a layer of abstraction that it would be hard to impose an abstract model on it. So now, having said that, there are parts of the UI that aren't in patterns, right? Because you can just sketch pages within Damask and draw things and whatever. And a lot of those things aren't going to be in a pattern. And so in those cases, in the background, we do create an abstract model so that we can generate the phone and the voice UIs in those particular instances. So I think there's this hybrid. But one thing that we did not do was expose that abstract model to the designers. Because in our previous work, when we asked designers about that, they said, well, we don't want to create abstract models. because that's like programming, basically, right? You're dealing at a, they like to deal in concrete artifacts, not in these, they don't want to be creating like trees of, boxes of stuff. So, so we do have this kind of hybrid approach. So we also asked the designers for just overall reactions to the tool. How useful and how usable was this tool? So when we asked them how likely would it be for them to use a commercial strength version of Damask, it was pretty positive, actually. You can see it's about 5 out of 7, which isn't bad. And some of the things that they liked about using Damask, they said it was fun. They said it was easy to use. They actually liked using the tool during our design sessions. And in an example of how important it is to get details right, several of them specifically said multiple undo. One of the great advantages of Damask is that it has multiple undo, right? Which of course we weren't studying. So, if you don't get a lot of these details right, then that can obviously color their impression of the whole tool, which makes research in tools pretty difficult. Some of the cons of Damask's interface, it has this hybrid of a sketch-based user interface and a more traditional UI layout tool similar to Visual Basic. And that hybrid confused people because they didn't know when to sketch versus when to go to the toolbox and insert stuff. So I think it would be better if we went totally to one model or totally to the other model, all sketch-based or all kind of UI designer-based. And they didn't have much real estate to use this tool. They were using a tablet PC with a stylus and a 1024 by 768 screen. That is painful. So, but we couldn't do any better at the time. So, now you got, large monitors, 1900 by 1920 by 1200. This would be a lot more feasible. There are many ways in which this work could be extended, especially in the area of patterns. For example, allowing designers to create their own patterns, to share those patterns with other people, to allow Damask to look through a designer's existing collection of designs and recognize patterns. I already talked about making it better for Damask to handle large patterns. It would be better, Damask should support annotations. So not only are the patterns not really annotated once they're included into the designer's design, designers cannot really annotate their own designs either. They can't create a page and then draw outside the page and say, this page is for X. And our previous research shows that that's really necessary. The concept of layers has promise but could be improved. And finally, going back to the discussion of the model-based UIs, how we're creating this model in the background. So we create this model in the background, and then we automatically generate, parts of the phone and voice UIs. But the way that those widgets are laid out right now is incredibly naive. They result in pretty ugly designs, and that's one of the things that our designers had to deal with. And so there are several projects out there that do a much better job of doing automatic layout. So two that come to my mind are the Gadget Project, which is done by James Fogarty and Scott Hudson. James is now professor at UW. And Supple, which is done by Christoph Gahos and Dan Weld. And Christoph was a grad student at UW and is now a professor at Harvard. So if we incorporated either or both of those algorithms as the layout algorithms into Damask, that would really improve the tool as well. Okay, so are there any other questions of Damask before I move on? Okay, so now I'm going to switch gears and talk about another project called Vegemite. And this project was done with Jeff Wong, who at the time was a graduate student at Carnegie Mellon, along with Jeff Nichols, Alan Seifer, and Tessa Lau, who work at IBM Research. So Vegemite targets the area of mashups. So as you probably know, mashups are web applications that integrate content and data from multiple sources. They can be quite powerful, and the architecture of the web makes it much more possible to do these types of apps than we ever could before. But they also tend to be very hard to create. Traditionally, you need to be a programmer to create mashups. And lately, there have been quite a few tools to try to make it easier to create mashups. So, for example, Yahoo Pipes or Microsoft Popfly. And but the thing about these tools is that the main, kind of the primary artifact when you look at mashups created in these things are the code, even though it's not traditional code, but it's the mechanism in which the data is being combined together. And what Jeff Wong found when he and Jason Hong worked on a project called Marmite was that a lot of their users didn't care about the mechanism. They cared about the data that was being created from the mashups. And they didn't necessarily care whether the mashups could be reused. They would have these one-off tasks. Oh, I want to figure out right now, combine from these two sources, and then I'm done. I don't care about the mashup anymore. And so we realized that there's this whole class of mashups that we're calling ad hoc mashups, where you just want to combine these data together. You got your data, and you're done. And so the focus should be on the data and not on the mechanism for combining that data. And so our general approach was to create these mashups, allow users to create these mashups by demonstration instead of by programming. So here's a screenshot of Vegemite. It's an extension for the Firefox web browser, and it consists of two main parts. Down here is the Vege Table editor, and this is the table where people will assemble and combine data from multiple sources. And it's obviously using kind of a spreadsheet-like model. And then on the left-hand side is the CoScriptor sidebar. So Vegemite was built on top of CoScriptor, which is another Firefox extension. And what it does is it allows users to record their web actions as a script and replay those scripts and share them with other people. And you can see that the lines of the script read like English. And so let's run through a scenario of how Vegemite would work. So suppose you're looking to buy a house, and one of your main criteria in buying that house is how walkable that house's neighborhood is. So in other words, is it within walking distance of shops and jobs and mass transit? And it turns out that there's a website called walkscore.com where you can enter an address into the text box, and it will calculate a score out of 100 of how walkable this neighborhood is. And so, this would be great information for you, except that your favorite website that shows real estate listings doesn't have this information. So you would like to combine that into one table. So I'm going to now switch to video and show you an example of Vegemite in action. So here I am at this website. I've entered in, I'm looking for 3-bed, 2-bath houses in San Jose. And I click search. So the first thing you'll notice is that the houses start at $1.7 million. And so now I'm going to take these listings, I'm going to scrape them into a table, into the Vege table. So I start the CoScriptor extension, and I create a new Vege table. And there's this import data from web page. I click on that, and then I'm going to hover over items within the web page, and you'll see that these items will get highlighted. And that's how you know what is going to be extracted into the table. And when I click on it, it's going to highlight all of the other items on that web page to show you, like, these are all of the items that we're going to extract. So you are essentially selecting data that's going to go into one row, and Vegemite will figure out the data for all the other rows in that table. So now I'm done. I clicked, done selecting extract. I name my table, and now I'm going to name these columns just so I can keep track of what data are in these columns. And so now I want a new column, a walk score column. So I create a new column. I label it walk score, and now I'm going to record a script that will relate an address to a walk score. So I create a new script, and then what I do is I do what I would do it how I would do it manually. So I go to walkscore.com, I go to the table, I copy the text from row 1 of the table. I paste it into the address text box. You can see the script being recorded on the left-hand side, and you can see this spreadsheet-like reference, copy column A of row 1 of the table. So now the walk score has been calculated. I copy that, and I paste it into my table. This is how you would do it normally. Could we wait until after the video? Thanks. And so now I've recorded my script. And I'm going to add this little hack, pause 10 seconds to allow the walk score to be calculated. A later version of Vegemite could detect whether there's text there or not, so you wouldn't have to do this anymore. I save my script, and so now what I'm going to do is I'm going to select all the other rows in the table, and I'm going to run that script. And so what Vegemite is going to do is it's going to apply the script to each row and update the row reference for each row. So now click Calculate Walk Score. You can see now it says row 2 instead of row 1, and it will just go through and replay my actions and slowly fill in the table. And now that, this isn't the world's fastest mashup because it's going to take at least 10 seconds per iteration, but this is still a lot less tedious than doing it manually. Yeah, did you have a question?
So what if we didn't do copy and paste, we just type the address in the box?
If you had just typed it, then it would have, our current system, it would just record it as a literal typing of that address. And so it wouldn't, as you ran it, it would just get the walk score of that particular address over and over again. I mean, you could imagine that if you typed it in, it could go through the table and say, oh, you've already typed this in, you really mean this particular cell, and record it that way, but we didn't do it that way. Okay, so that's Vegemite. So let's talk about some of the parts of Vegemite, the tables, extracting data into those tables, and then running scripts over those tables. So our Vege Tables use a spreadsheet metaphor, which is pretty familiar to a lot of people. And these tables are being stored on the same server as the scripts that run over those tables. So even though we are not doing this now, this opens up the potential to share tables with other users of Vegemite. So when we extract data into the table, as I said, the user selects the elements in the web page for one row, and what Vegemite does is it looks at what you selected, generalizes the XPaths, and then automatically selects the other items. And this is similar to a lot of other existing screen scraper applications. The first two are industrial applications that are out there, and there's also been a lot of research in this area. And this isn't doing anything that different from those projects. But one thing it is doing differently is this idea of running scripts over these tables. So CoScriptor scripts embody the user's actions in a web browser. And the lines of the scripts read like English, basically. So they are literally things like enter the submit button, and click the submit button, enter your name into the search text box. And we did a couple of things to extend CoScriptor for Vegemite. We added the ability to understand copy and paste, and this provides simple on-the-glass integration so the websites don't need to know anything about Vegemite. And we extended CoScriptor so that understands table operations. Yes?
So if you can go back to the previous video.
Go back to the video?
Where you had the table. Yeah. So what if instead of first creating the entire table, I do 2 browsing sessions in parallel? So I take the name of take the address from one website and put it there, and then go to compute the walkability score. So can it also compute the same result under that scenario?
I mean, Vegemite can't do that right now, but I think that would be a really interesting approach. Like you could imagine. So wait, are you saying that like like opening another window and doing it that way.
So I don't want to think of the tabular abstraction because you're forcing the user to think of the tabular abstraction and get the entire data as one's first step.
Yeah.
And then operate on the tabular, which is nice actually because they get to use the spreadsheet abstraction. But what if they did not think about it this way?
I mean, I think it's a great idea, like what you said about having parallel web browsing sessions kind of instead of the table. And it's true that some people had kind of issues with the spreadsheet metaphor and how things were set up. So yeah, we can talk about it more. But I think that's an interesting idea. It doesn't support that right now, though. Yeah.
Couple of questions. One, you said that the tables are like being stored on a server. They're not on the user's local machine.
That's right.
Is that the same with the scripts as well?
Yes.
And also, are these add-ons only available for Firefox at the current moment?
Currently, they're only available for Firefox. Yeah.
Oh yeah, how do you do with the thing where the website only gives you like 3 entries at a time, and you have to keep on hitting the next button?
Right. So I don't believe we don't deal with that right now, but there are screen scraper applications that do deal with those types of things. So essentially, we would grab one of their algorithms and use that instead. But yeah, certainly, like if there are like 5 pages, you don't want to be going through and selecting those manually. And I believe there's been other work in our group that starts to deal with that, or that at IBM.
I guess similarly, can you also do things like after it's selected all the table, maybe the first one is always wrong, it's the title or something, or like, can you manipulate a little bit in the script and say, so it knows like, oh, it's always select this table except the first item.
Right, so I mean, you can't modify,
the script doesn't actually select the data at all, right?
It's just copying from the table itself, kind of one cell at a time. And you can actually go ahead and modify the contents of the table manually. So if it turns out that, it grabbed some data that wasn't great, I'll just select a row and delete that row, or I'll just kind of clean it up manually. And of course, there are data cleaning solutions that are out there. We don't incorporate them, but you would want to have that type of thing as well if you're going to do screen scraping. You can actually also, I don't know if this screenshot shows it, but there's actually a way to import data from an existing spreadsheet and so on, like an existing like CSV file in here, so that you're not necessarily starting from a website.
So back to my earlier questions about can you export the scripts or the Vege table information to the local machine?
Yes. Yes, you can. So both the scripts can be saved out to the local machine, and that's kind of the co-scriptor part. And they're, I guess this is a slightly older screenshot. A newer one, there is also an export, and you can export as essentially either tab or comma delimited text file. And that also allows you to, obviously import to other tools pretty easily, right? If you want to do data visualization and that type of thing. Yeah. Okay, so as I mentioned, we extended CoScriptor to understand running scripts over rows of a table, and so it knows what the currently selected row is in a particular table, and it can update row references. And so because Vegemite and scripts have access to the whole web, you can imagine these scripts being used for more than just data manipulation. So for example, Vegemite doesn't have an email command, but there are all sorts of email web services out there. So you could imagine writing a script that goes to Gmail, that copies data from the table, pastes it into the to box, and goes ahead and mails out people. Now, if you're wondering if you're worried that Vegemite has now created yet another way to create a spamming tool, you should know that since it's replaying web actions in real time, it's going to be the world's slowest spamming tool, because you'll see Gmail get loaded up and the compose mail get clicked and so on. So, it really isn't meant for that. It's just meant for kind of one-off type of operations. Maybe I want to do a mail merge with like 6 people, and Vegemite would be good for that type of thing. And so what's interesting about this is that you can, you don't necessarily need to extend Vegemite's language to be able to add new features. You can just use the web itself. So, there are websites that will do unit conversion or check the weather or things like that. And so you could have a Vegemite script be able to use that website as essentially a service.
So since each row is independent, did you consider parallelizing so I could just run 10 rows at a time? So it'd be it's ad hoc and one-off anyway, and I just want it to be done as fast as possible.
Right. I mean, the reason we didn't do that, I mean, that's a great idea. The reason we didn't do that is because it's running within one particular browser instance, and if we wanted to do that, we'd have to farm out, n different browser instances. I mean, I know that in relation to another project, we've gotten the browser to run on a server, basically a kind of headless browser and a server. And so if you did it that way, then you would be able to do it parallel.
Also, along the same lines, there is, rather than having like the go-to blah blah website command in your script, could it work that it's switched to that website in an already opened tab?
Yeah.
Is that supported?
Since I haven't been associated with the project recently, I don't know if that is now supported currently or not, but that was certainly in the plans to switch to a particular tab, to open new browsers in a tab, and so on. And yeah, it would save the cost of constantly reloading that particular page, because you could just switch to a particular tab, paste in that data, and just kind of keep going. Yep. Okay, so we did a formative user study of Vegemite to see if anyone would be able to understand it and to be able to use it. So we got 8 volunteers. Unfortunately, given the fact that we're trying to target non-programmers, 6 of our 8 volunteers were programmers, and 2 of them had actually created Mashups before. But, maybe if they couldn't get it, no one could. So it was still interesting to see what issues that they would come up with. They had 60 minutes to use this. And first we demoed Vegemite to them, where we went to imdb.com. They have a top 250 movies list as determined by their users. And we demonstrated how to add a director's column to that table. And then we had them do 3 tasks. The first one was the real estate walkability task that I showed you in the video. So that mashed up mercurynews.com and walkscore.com. The second task was to find the distance between all yogurt places in downtown Palo Alto and a particular location. And so that mashed up Yahoo Maps and the Yellow Pages. And finally, there was one particular page which had a whole bunch of different tables, and they were supposed to write a script to kind of aggregate data across all of those tables into one table. And this is related to things with visas at the State Department. And so there were 24 tasks were done, 8 users by 3 tasks, and 18 of them were completed successfully, which is not bad. 4 of them were not completed. 2 of them were the first task, so that shows that there's a decent learning curve for this. 3 of the 4 tasks that were not completed by non-programmers. So we certainly have work to do in getting a UI understandable, more easily understandable by non-programmers. And then 2 of them were skipped because we just ran out of time. And so when we asked them for their experience with using Vegemite, one thing that they mentioned, and this kind of gets to the question of the parallel browsing idea, was that people had a hard time understanding the concept of filling in a whole table versus filling in one column of a table. Because to fill in a whole table, you do screen scraping, and to fill in one column, you record a script, and they're really different. And people had a hard time understanding when to do one and when to do the other. Also, the the concept of adding a column and then the concept of recording a script to fill in that column, those UI elements weren't very well related together. And so people had a hard time trying to figure out when to do what. So possibly, we should add like a new script button over each column. Now that you've created a column, let's fill it. And finally, the Vege Table interface at the bottom and the sidebar interface on the left, they're very separate, which isn't surprising because they were developed kind of separately. But it shows that it kind of spreads the concepts apart across the interface too much. So I think there would need to be a fair amount of redesign to kind of unify those together.
Do you expect to use it like a spreadsheet? Because it looks like a spreadsheet.
Right. I mean, I don't believe we ever saw people trying to enter formulas or anything like that. So I think they...
Like deletes, edits.
But the table was actually live. So you could actually go in, edit the data both before and after the any of the scraping and running scripts and stuff. It was actually intentional because we figured that even with these tools, screen scraping and running these scripts, sometimes the scripts won't work quite right because the web page formatting gets a little weird and so on. And so we wanted to allow people to go back in and say, well, these two cells aren't quite right. I'm just going to edit them right here. So interestingly enough, all of our users said that they felt comfortable with Vegemite. They kind of got the basic idea, and a few of them even asked if they could get a copy.
Were they able to distinguish the difference between CoScriptor and Vegemite?
We presented it as if we were kind of presenting it as one system. So I don't think we ever asked them, do you know the difference between this and that? But I think they saw a difference between the table and the scripts. The scripts are being run up here, the table is down here. And so I think they actually got confused by that. But I don't think we said, here's CoScriptor, and then we added this new thing.
Well, I guess, when you said they felt comfortable with Vegemite, maybe they felt comfortable with part of it.
I see. That's a good question. I'm not sure. I'm actually not sure whether they meant only the table part versus the whole thing. It would be good to go back and take a look.
Isn't that what you meant by sidebar? The fourth bullet, like the third bullet?
Well, that one is the Vege Table interface particularly.
With the sidebar, okay.
Well, with this, as opposed to Vegemite, which is both.
Okay.
So, of course, there are ways in which this research can be extended as well. So one of them is how these scripts could be generalized, which is an age-old problem in programming by demonstration. You record something, how do you know that this part could be generalized? So, for example, right now, the rows are parameterized. You can, as you select rows, those row references can change. Would it make sense to do those for columns? When someone selects, for example, if someone selects two words between foo and bar, what are they trying to do? Are they always trying to copy the first two words after foo? Are they trying to copy all of the words between foo and bar? So there can be multiple interpretations. Right now, Vegemite just picks one, and you should be able to select from a list. We haven't looked into how Vege Tables could be reused. So both whether the data within it could be shared with other people, or you have a blank table and you want to share the scripts that are attached to it, which sounds kind of like methods and objects and stuff, right? It gets kind of interesting. You can start thinking of this as a programming language, essentially, a full-fledged one. And then connections with other tools. So we started talking about being able to export data from Vegemite into a file and then loading it into a data cleaning solution or a data visualization solution. And it would be even better to integrate those tools directly into Vegemite. And then finally, we should study more non-programmers and understand, where they're coming from. So as an aside, you may be wondering, why did we call this project Vegemite? So Jeff Wong, who was an intern on our project, worked with Jason Hong at CMU on a project called Marmite, because Jason has a theme of naming projects after disgusting foods. So So they have Marmite, and that was published at Chi. Meanwhile, CoScriptor was originally called Koala because Tessa Lau had just gone to Australia the week before we started the project. And the Australian version of Marmite is Vegemite. So that's why. So that's all I have. And if you want to find out more about these particular projects, those are the URLs and those are the conferences that they were published in. Thanks. And I'll take more questions if anyone has any more.
Try to summarize the differences between Vegemite and Dapper.
So Dapper, at least the last time I looked at Dapper, it was more about kind of screen scraping data from pages and from multiple pages. But I don't believe it had the concept of combining data from multiple websites, or like how you can use data from one website to drive extracting data from another website. So I think, we could use Dapper potentially as the interface for scraping the data into a table. So that's the relationship I see between them. Okay.
So is Google interested in this technology?
Good question. I'm not sure yet, although for Vegemite, we filed a patent at IBM. So, so I could present it at Google, but then we'd have to somehow work around it and so on. So, but there would be some obvious fits of this type of work at Google.
Does CoScriptor basically allow in its scripts? Does it allow for you to, if you're the geeky programmer type, you want to get under the hood of the script and basically figure out what regular expressions it messed up that
right.
It's getting the wrong results?
Right.
Does CoScriptor allow for that?
It does now allow for regular expressions. So if you, so you can, and that even deals with things like, okay, copy the text after the word files. And maybe it only says file sometimes. Currently, only a regular expression could deal with that. I think ideally, we would have a better interface than that because regular expressions are really hard. But we did get feedback for Vegemite and CoScriptor in general about allowing kind of power users to be able to add, kind of more features, to be able to do things in more details. Like, I know what's wrong, let me try to fix it. So we have slowly added some of those things. I will add that CoScriptor, you can download CoScriptor and use it from that URL. I don't know if the Vegemite functionality has been enabled or not. I know that was part of their plans.
When you're looking at non-programmers thinking about mashups, do they even conceive of ideas of things like, I want to be able to take all the houses on this list and combine them with the walkability scores in an Excel spreadsheet? Or do they use different concepts to describe what they want to do, or even come up with those ideas?
Right. That's a good question. I know that I believe Chris Scafidi has a paper about like looking at how people think about, actually maybe it wasn't Mashups, I think it was end user programming types of tasks in general. But I personally feel that one of the issues with end user programming is kind of letting people know that these types of tasks are actually possible, because they're used to using this particular website, that particular website. Those allow you to do X, that's all I can do. They don't start thinking about, this data lives separately from these things, I should be able to start mixing them up and doing whatever I want. And I think that's actually a big challenge in this area overall for adoption of these types of tools, is letting people know that you can actually do this, and have people start thinking in those ways.
So if you can go back to the discussion slide, last one. Yeah, the future work actually, yeah. The future work slide.
Oh, future work slide,
So can you say a little bit more about this generalizability of scripts? So what are the things we like to generalize? So you say it's in a Howard column. So you want to have scripts which will feed different items on the web page into different columns. Is that the idea? Or
Right. I mean, the reason it's a question mark is because we're not exactly sure whether that's useful or not. Like, but you know, but the idea would be just like we record a script and then select a bunch of rows and say run the script over these rows, and then the row references change. You could record a script, then select a bunch of columns and say, okay, run the scripts over these columns and have the column references change as well. I mean, the way we were looking at it is that, you know, currently in Vegemite, kind of each entity is one row, you know, in the table, and then the columns, you know, are properties. That's almost like actually more of a database model than anything else. But there's nothing, but like a spreadsheet, there's actually nothing internal to Vegemite that constrains you necessarily from that, except for the fact that scripts are only generalizable among rows. So, so that's what we were wondering is, would it make sense to even have scripts that go along columns or not? And that's all.
Also, are there some scenarios that you want to capture which you cannot currently capture using this technology? That motivates probably in the second bullet on your future work slide.
I mean, I think there are kind of more. It's a lot of the things are related to the limitations of CoScriptor in terms of what's the type of data it can reliably extract from a web page. How does it label that particular data so that when you replay the script, it's going to grab what you think is the correct data?
The XPath expressions are not good enough by themselves?
Sometimes they're not. It depends on how the page is laid out. So for example, if you're at a page where you need to log in, right? So if you're not logged in, it will say like, you know, welcome, log in. And if you are, and with a text box, and if you are logged in, that text box isn't there anymore, which may change the number of text boxes in the rest of the page. And so like your references are wrong. And so I believe we actually have run into some of those issues in CoScriptor. And so the labeling that the XPath generalization that we do for extracting data into tables, that labeling is separate than the labeling that we do in CoScriptor when we say copy the text after address. So in that case, the data is actually labeled as after address. When that line gets executed, it goes through the web page, tries to find the label address, and then copies the text after that. So I think, you know, and sometimes that works really well, and sometimes because of the way web pages can be written all sorts of random ways, it just doesn't work. You know, people do weird things with the DOM and so on. I believe in Gmail, a lot of the links weren't actually links; they were spans with a on-click handler attached to them, and so you can't find them through the standard "give me a hyperlink." So you know, it's a lot of those little things that CoScriptor in general needs to deal with. Okay. Last question.
Is CoScriptor smart enough, like for the walkability scores? Is it smart enough to realize, okay, the user happens to be selecting a number here, so make that part of my criteria?
It's not that smart right now. I know there's a project by Chris Scafidi, who's now at Oregon State, called TOPES, and it's about making it easy to do kind of that type recognition and extraction, so that, you know, ideally you would copy like a phone number, and not only would you get the phone number, then you could say, now take the area code of that phone number and do X. So TOPES allows you to do that, and we have had experiments with integrating TOPES into CoScriptor.
All right. Thanks, Jimmy. And let's thank our speaker.
Thank you.